the mean weight of the product is 50 kilogram. 50 kilogram. The standard deviation of their variation is 5 kilogram. In the quality assurance department, we take a sample of 100 products. What is the chance that the average weight of the sample is more than 55 kilogram? So, is this question about the products?
No.
Let me ask you another question. What is the chance that a randomly selected product is more than 55 kilogram? I hope that you are taking note. I hope that you are paying very careful attention. These are totally different questions. And for the second question, you already are equipped to answer the question. The only thing that I need to tell you is that the weight follows normal distribution. The weight of products follows normal distribution.
Amir, can you please repeat? So I understood how we got to the 0.3 and the standard deviation of that area. What comes after that?
For question 2,
Yes.
yeah, so basically this is what people said. They have drawn a normal curve. They wrote here normal. In the middle, they said mean is 50. Standard deviation is 5. And their point of interest is 55. Did you do the same thing?
Yeah.
Yeah. And then we actually want more than 55, but that is not possible to be found from the table. Therefore, we are finding this area first. And to find that area, we have to find what is the Z for 55. What did you get for Z for 55?
0.3.
No, 55
Oh, that's the
minus
area.
50 divided by 5. We want to know how many standard deviations.
One.
Yeah, 55 is far from 50. So it's only one standard deviation far from the 50. Do you have normal table in front of you?
Yeah.
Yeah, I want you to tell me how much is the area between mean and Z1.
3413.
3413. So this is
Yes.
3413. Therefore, the green area would be 0.5 minus 3413, which is 1.5787. Good?
Good. Yes.
Okay. Any other questions? So the chance that a product is more than 55 is 15%. near 16%, right? But the first question, what is the first question asking? It says, I will give you the circles in the exam. You have to annotate the circles and the normal curve. The question says that we are taking a sample of how many products? 100 products. The mean of the population is 50. The standard deviation of the population is 5. We take a sample of 100 products. So these products, let's say, what are they? Let's say they are chairs. We take the sample of 100 chairs. And then we find the average of those chairs. What is the chance that the average of these chairs is more than 50? Do you think it would be more than 15% or less than 15%? Because the chance of one chair to be more than 55 is near 16%. What is the chance that the average of 100 chairs would be more than 55? Is it more or less? Just tell me how likely you think it is that the average of 100 chairs is more than 55. Just your feeling. I want to know your gut feeling. Some of you, please express your feeling.
Less?
If the average of the population is 50, what is the most likely average of the chairs in the sample?
50.
50.
Exactly. For the average of the sample to be 55, there should be some of the chairs with a weight of 60, some of the chairs with a weight of 50. So for the average to move toward 55, we need a lot of chairs that are really heavy at 60. Otherwise, the average will not move to 55. Do you see that? So without doing any calculation, we think that this X bar shouldn't move very much toward 55. Any other reason that you can bring? The other reason is that some of these chairs, they are taken from a population with average of 50. Some of the chairs would be more than 50, some of the chairs would be less than 50, and they cancel each other in the sample. There are 100 chairs, and they are taken from an average of 50. Some of them are less than 50, some of them are more than 50. Their average doesn't move very much. So our feeling says that the answer to the first question would be much smaller than 15%. The average of these 100 chairs is not going to be very much bigger than 50. Now let's use the knowledge of central limit theorem. Question 1 is about the distribution of X bars, while this question, that question 2, was about the distribution of chairs. From now on the left side of every normal curve, you have to tell me this is the distribution of what? Can be distribution of people, can be the distribution of chairs, can be distribution of bags of chips, whatever it is. So when you were answering the second question, you were answering a question about chairs, that they had normal distribution. But now we are answering a question about what will happen to average of a sample. Okay? Therefore, this is a normal distribution based on CLT, or I would rather to say central limit theorem tells us that it is normal. Also here, it's not mean of the chairs, it's the mean of X bars and the standard deviation of X bars. What would be the average of all possible sample means based on central limit theorem? Look at your table. I already told you. What is the mean of all of the X bars? Look at your notes. We just covered it. You're taking note. You can get a bonus mark. What is the mean of all of the x bars?
5.
It's mu, so 50.
Who said
50.
that? There was a lady who said that.
I did.
You said it is mu based on central limit theorem, and we know that the mean is 50. Do we know what is the standard deviation of x bar? It's the standard deviation of the population divided by the square root of n. Who told you that? Central limit theorem. Yeah, repeat that. You have to, in the next 2 months, when you are sleeping, when you are walking, you always think of central limit theorem. So repeat it, get used to it. Based on central limit theorem, the standard deviation of x bar, how much x bar varies, is the standard deviation of the population divided by square root of 100. Therefore, the variation of x bar is, help,
0.5.
0.5.
0.5. So these vary very little. Now that we have a normal distribution that we know everything of, the point of interest is more than 55. Therefore, the area of interest is more than this point. And to find this area, we cannot find that area, but we can find this area. And to find this area, we need to find what is the z for 55. And the z for 55 is how far is 55 from 50. What is the standard deviation? What is the standard deviation?
0.5.
5.
5. And z, how far is 55 from 50?
5.
Now you have to subtract 55 minus 50. You divide it by the standard deviation. Z
10.
is how many standard deviations we are far? 10.
10.
So this point is 10 standard deviations far from the mean. Please go to the table and find z equal to 10 and tell me how much is this area.
It's not on the table.
What is the biggest number that we have on the table?
3.99.
3.09. 3.09. So, and the area for 3.09 is 0.499. And if you go 3 standard deviations far from the mean, this blue area is 0.49. If you go 10 standard deviations far from the mean, then the blue area is 0.49999999999. Therefore, the green area is very close to
Nothing.
the center
Zero.
point to
0.5.
infinity is 0.5. From the center point to end of blue is 0.49999999999. Therefore, this green area is
0.01.
it's very close to 0. Therefore, the answer to the first question is 0. And that's a very important lesson. What is the chance that we take one chair and it is more than 55 kilogram? What is the chance that we take one chair out of these chairs and it is more than heavier than 55 kilogram?
0.
No.
Close to
One
0.
chair.
0.1%.
Notice that this question
Oh,
was
0.1.
a product.
Yeah, 0.1.
15%, 16%, right?
Yeah.
What is the chance that we take 100 chairs and the average of those 100 chairs is more than 55 kilogram?
0.
0, because some of them are more than 55 and some of them are less than 55. They cancel each other. It is very unlikely that the average of 100 chairs is more than 55. And that's the importance of central limit theorem. It tells us that the mean of a sample does not vary very much. I want you to write that sentence as the conclusion, and we will finish today's class with that, and you have to upload the result. Therefore, the mean of the sample or X bar does not vary very much. One share value can change very much, but the average of 100 shares does not change very much. Therefore, the average of the sample remains very close to the average of the population. Combine all of your pages to a PDF and upload. Starting today's class, I will be picky on your properness of hashing and the colors that you're using and your references. Yeah, so annotation of the normal curve will become more and more important, especially from now on, because sometimes we are talking about products and sometimes we are talking about the average of the products.